be looking at how we can solve problem connecting displacements, average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. But before we go into solving the problem, I want you to understand certain things. If you are asked a question, you need to know the particular question, what that question is asking you exactly. And that is what will make you address the problem. What do you mean by instantaneous velocity or acceleration? Instantaneous velocity is the velocity at that particular time, at that particular instant. And then when you are talking about average velocity, it's a different question. Instantaneous velocity is different from average velocity. That is, when you are talking about average velocity, you are talking about the average or the total distance covered with reference to that time. The same way we're talking about instantaneous acceleration. Instantaneous acceleration is acceleration at that particular, the rate of change of velocity at that particular time, at that particular instant. So these are the things. So we have a problem here. Suppose the motion of a particle is described by the equation x equal to a plus bt square, where a is 2 meters, b is 4 meters per second square. A, find the displacement of the particle in the interval. T1 is 2 seconds, T2 is 5 seconds. B, the average velocity of the particle in the time interval, referring to T1 and T2. C, the instantaneous velocity at T1, that's specific here. D, the average acceleration, and E, the instantaneous acceleration at T1. So let's look at it. So when you are talking about, we are given A as 20 meters, B is given as 4 meters per second square. Then change in time is T2 minus T1, which in this case is 5 minus 2, which is equal to 3 seconds. These are the parameters given here. And then the first question is, with the reference equation, we can calculate displacements, which say that x is equal to a plus bt squared. And all the parameters are given here. So in this case, we have x is equal to 20 plus 4. Our time now is 3 square. So this is equal to 20 plus 36, because if you square 3, that's 3 times 3, 9 times plus times 4, sorry, it's 36. So if you add up that, x now will be equal to 56 meters, which is the displacement. The B part of it, the average velocity. Remember, in one of the classes, we derived the equations of motion. I will say that S is the total distance covered, is the average velocity all over times time. This term here is what we call the average velocity. So we can say that S is equal to average velocity times time. But what we are looking for here is the average velocity. So by the time you divide both sides by t, we now have s. The average velocity becomes s all over t. That is the total distance covered all over time. So the formula here will be average velocity will be equal to distance all over time. In this case, it's represented by x all over t, which is equal to the total displacement. We've got 56 all over time is 3. And by the time you do that, you have 18.7 meters per second. 18.7 meters per second. That is the average velocity. Then see the instantaneous velocity at that time. The instantaneous velocity at that time. Displacement all over time. But here we're talking about T1. That's specific about T1. And what is T1? T1 is 2. So this will be equal to 56 by 2, and that gives us 28 meters per second. So you can see that the average velocity is 18.7 meters per second, and then the instantaneous velocity is 28 meters per second. So next we'll look at the average acceleration. Average acceleration. We're talking about the average acceleration. We're talking about the average velocity all over time. Average acceleration is average velocity all over time. And what is the time? Is 3. So the d part of it, average acceleration, is equal to average velocity all over time, which is equal to 18.7 divided by 3. That gives us 6.23 meters per second square. The D part of it, the E part of it, sorry, the instantaneous acceleration. The instantaneous acceleration. That is E, instantaneous acceleration at T1. Already we have calculated the velocity. You need to be very careful. Average velocity is calculated to be 18.7 meters per second. The instantaneous velocity is calculated to be 28 meters per second. So here we are talking about the instantaneous acceleration. So instantaneous acceleration will be equal to v all over t1. That is the instantaneous velocity all over t1, which is equal to the instantaneous velocity is calculated to be 28 all over t1 is what? 2. And that gives us 14 meters per second square. So these are the values. So before we go, always know what the question is all about. What the question is asking. Is it asking you to calculate the average velocity, instantaneous velocity, the average acceleration, instantaneous acceleration? These are different concepts. So once you know what you are asked to do, then you approach it with precision. Thank you.